Hi everybody, welcome to our channel EASI. Everything about semiconductor industry or everything that you need to know about semiconductor industry. So today our session is about semiconductor ecosystem. So it's an introductory session where we will cover how this revolutionary industry started, some of its important inventions and the key milestones that led to where we are today. So without any further ado, let's get started. As we all know, with AI boom fueling an unprecedented demand for advanced semiconductors, this industry is rapidly growing and it's going to hit trillion-dollar market pretty soon. Along with that, its number of key players are increasing day by day, making it a significant market for all of us. So the question is, where did it all start? It all started with the birth of transistor. Transistor was invented by three physicists, namely John Burdeen, Walter Brattain, and William Shockley. This invention was done in 1947 at Bell Labs. For this, they were also awarded the Nobel Prize for Physics in 1956. This invention revolutionized electronics, enabling the development of integrated circuits or ICs by 1958. Thus, laid the foundation for the modern semiconductor industry as we know today. That brings us to the question, what is a transistor? A transistor is a semiconductor device that replaced the previously used bulky vacuum tubes, which amplifies and switches electronic signals in a more energy efficient way. Now let's talk about some of the key innovations in this transistor development. The first ever working transistor was called point contact transistor. As the name suggests, it uses two closely spaced gold contacts as the emitter and the collector, and they were pressed against the surface of an N-type germanium crystal using spring mechanism. And this, for the very first time, demonstrated the mechanism of a transistor which amplified the signal. It was really groundbreaking. However, it was noisy, fragile, and non-manufacturable. Thus, it was soon replaced by BJTs. A BJT is a bipolar junction transistor, and it's a three-terminal device which has base, collector, and emitter, and it uses small current at the base to control a much larger collector to emitter current. BJTs function as amplifiers or switches and are classified as either NPN or PNP, which utilizes both electrons and holes for the charge transfer. After that came MOSFET. MOSFET is a metal oxide semiconductor field effect transistor. Unlike BJT, it is a voltage controlled semiconductor device which operates by using a gate voltage to create an electric field that controls the current flow between the source and the drain terminal. While BJTs are better suited for amplification, MOSFETs are faster, more efficient for switching, and have high input impedance. It is one of the mostly manufactured semiconductor device so far and is the foundation of modern day microprocessors. Now let's talk about some of the key milestones. To start with, let's talk about the emergence of the Silicon Valley. In 1960s, Silicon Valley became the epicenter of semiconductor innovation, with companies like Fairchild Semiconductor paving the way for rapid technological advancements in microelectronics. Fairchild was founded in 1957 by the famous 8 scientists who left Shockley Semiconductor to create a company focused on producing silicon transistors. Fairchild soon became an incubator where 30 companies were found by former Fairchild employees. Among them, some of the notable spin-offs include Intel and AMD. Now, let's discuss about Moore's Law. In 1965, Gordon Moore predicted that the number of transistors on a chip would double approximately every 2 years. Moore's Law not only acted as the guiding principle but also became the self-fulfilling prophecy that set the path and the pace for the entire industry, that forced the companies to keep up with their competitors for both miniaturization and performance. With that came Intel's 4004. It was the first ever commercial microprocessor. It was a 4-bit CPU that featured around 2,300 transistors and was designed for a printing calculator. It used 10 micrometer technology, and it was not just the first chip but revolutionized computing by presenting programmable logic in a 16-pin package. Thus led to the rise of personal computers. By 1980s, personal computers became widely accessible, fueled by advancements in semiconductor technology, transforming how people interacted with technology in their everyday life. With that, we have come to the end of our today's session. In the next video, we will talk more about the ecosystem, how miniaturization trend is powering future electronics and driving innovations, Moore's Law and beyond. So if you liked our video today, please like, share and subscribe. See you next time. Till then, take care and stay safe. Bye.